Okay, let's look at this past paper question on electricity. Up the top here, I've got the formulas. This one is not in your formula sheet, but remember I said you can easily remember this. But the series resistance formula and the parallel resistance formula will be on your data sheet. Okay, consider the circuit diagram below. Switch S is open. So if you have a look here, we've got some batteries, we've got an open switch, we've got two resistors in parallel, and one resistor in series. They're all 8 ohm resistors. And then we've got voltmeter 1, ammeter 2, ammeter 1, ammeter 2, ammeter 3, something like that. They've all got a number, okay? Those ammeter things are quite small for me to read. So now it says to you, let's look at the questions. Write down the reading on the following. Remember, switch S is open over here. When the switch is open, what will the reading on the voltmeter be? There is actually a reading on the voltmeter, and it's going to be 24 volts because that is the maximum EMF supplied by the battery. Remember, we've got a potential difference and an EMF, and the potential difference is when there's current in the external circuit, and the EMF is when there's no current in the external circuit. So this is 24 volts EMF, which is 24 volts. In ammeter 1, there is going to be 0 amps flowing in ammeter 1. Because the switch is open, the electrons will leave here and they cannot return home, so there cannot be any current flowing because an electron cannot get around the circuit, so no amps. Calculate the equivalent resistance of the circuit. Okay, wait, we've closed the switch now, yes? Calculate the equivalent resistance of the circuit. So now remember, the resistance is going to be the resistance in series plus the resistance in parallel. Okay, so we can work this out. What is the resistance in series? The resistance in series is going to be that 8 ohms. Okay, maybe I must look for my ohm character. Where's the ohm character? Okay, but now we need to work out the resistance in parallel, and so what we're supposed to do is go 1 over R total equals 1 over R1 plus 1 over R2. But I'm just going to use this cheaty formula, the quick and dirty, the product over the sum. So I'm going to say to you R parallel, but you must write the formula. I can't because it's fractions. Okay, so this is going to be 8 times 8. Okay, so that is the product over here. 8 times 8 is the product, and I'm going to put it over or divide it by 8 plus 8. Okay, so 8 eighths are 64 divided by 16. I reckon this is going to come to 4 ohms. Okay, so I found my resistance in series, I found my resistance in parallel. So my total resistance of the circuit, or my equivalent resistance as they call it, is 8 plus 4 equals 12 ohms. Okay, so there's my final answer. My equivalent resistance is 12 ohms. Calculate the reading on voltmeter 2. Okay, now if we look at this circuit here, okay, we can say these two 8 resistors have an equivalent resistance of 4 ohms. Remember, we worked it out over here what the parallel resistance was. If we say that these two have got a resistance of 4 ohms, we can consider that we have an 8 ohm resistor and a 4 ohm resistor in a series circuit. Okay, so that's what you can do with parallel resistors. So we've got an 8 ohm plus a 4 ohm. In a series circuit is a potential divider. So what you can do here is you can say here the voltage is going to be divided, okay, in a ratio of the resistors. Okay, so we have the total resistance, so let's have a look at what the ratio is. The ratio is 4, which is the parallel, is to 8. Okay, altogether there's 24 volts in the circuit. The battery provides 24 volts, okay? So we're going to split up this 24 volts because resistors in series are potential dividers. We're going to split this 24 volts up in the ratio of 4:8. So if you look at this 4:8, it's the same as 1:2. So we can say we want to calculate it on voltmeter 2. This is voltmeter 2. So the 8 ohms is the larger part, okay? It's going to get more voltage in the 8 ohm resistor. So if we put this as a fraction, you have to add these two together. What's my total resistance is 12, and then this resistor is 8 parts of the 12 parts, okay? Or you can say that it's 3 parts if I've reduced the ratio here, and it's the larger part of the 3 parts, so I'm going to say that it's 2/3. Okay, well, which would you prefer? We can say 8/12, which remember I said it's 4 plus 8 is my total of my ratio, times the total voltage in the circuit, which is 24. So 8/12 times 24 is 16 volts. So you can work this out using the ratio of the resistors and the knowledge that a series circuit is a potential divider. Then it says to you, how do the readings on ammeters A2 and A3 compare to each other? A2 and A3. I'm assuming these two are A2 and A3. I can't see nicely. So they will be the same. Yeah, they will be the same. Why will they be the same? They will be the same. It's only 1 mark, so we don't have to explain. But why will they be the same? They'll be the same because these two are the same size resistors. Yes, the current is going to split up through them, but these two resistors are the same size, so the current's going to be the same through both of them. Okay, let's look at the second part of the question. The graph below shows the relationship between the resistance and the length of conducting wire. Write down the relationship between the resistance and the length of the conducting wire. Okay, this graph is a straight line. A straight line shows you a directly proportional relationship. So we like to write that in physics. Write it as it is a directly proportional relationship or something like that. So you can say here, the resistance is directly proportional to the length of the wire. If you don't want to write it like that, okay, oh sorry, before we go any further, we can only say it's directly proportional. You can say it is proportional if you get a straight line that doesn't go through the origin, but this line goes through the origin, therefore it is directly proportional. If the line doesn't go through the origin, you have to use proportional versus directly proportional. You can also say the simpler way of saying this is the resistance increases as the length of the wire increases. Okay, now it says to you determine the resistance of wire with a length of 30 millimeters. They just want you to read this off the graph. Okay, so if they want you to read this off the graph, you have to get up close and personal. You find 30 millimeters over here, and then this is 1 and this is 1,5. So all of 2 little blockies is 1. So this is going to be 1,1, 1,2, 1,3. It looks like it's in the middle there. It's going to be 1,35 ohms. That is the resistance of the wire. I've just gone up the x-axis and read off the y-axis. And this question is now complete.